welcome to Casa de Gucher. I ran out of time to do your mini lesson at school today, so I thought I would bring my minerals here and create my mini lesson for you here in my backyard. So it's going to be kind of interesting for you. You get to get a little sneak peek of where I live and what my place looks like. But more importantly than that, you are still going to be learning about minerals, what makes a mineral, how you identify them, and just pretty much why minerals are cool. So let's begin our lesson.
One of the main reasons why I like minerals so much is basically because they're pretty. They're fun to look at. If you look at them, they come in all sorts of different colors. Sometimes they're just really weird. You want to touch them. You're like, really? This was formed in nature? I think that's pretty cool. Nature pretty much rocks. Even though these are minerals, they are not the same thing. Minerals make up rocks. The first thing you're going to need to know for that quiz that you're going to be taking is that there are 4 characteristics of minerals. And for it to count, it must reach all 4 requirements. The very first thing you can see here is that it's formed in nature. So this isn't man-made. These are formed by natural processes. It must be a solid. One interesting thing is that an ice cube is considered a mineral. However, water in its liquid form is not. So very interesting. The next thing, it has a chemical makeup and it has a crystal structure. Now I don't have a lot of chemicals here to show you what that will look like, so we're going to use this page here. Chemical makeup just means it's made up of elements. So these are atoms of copper and they form the mineral copper. Where halite is made up of 2 different elements. It is made up of chlorine and sodium. So when those come together, they make halite. So this chemical makeup, actually you can kind of think of it more as it's just a recipe for minerals. Minerals are made up of chemicals and elements. Okay, when we're talking about crystal structure though, I do have examples of that, but just a reminder, a crystal does not mean that it's really, really expensive or valuable. Crystal is just a solid that has a specific repeating order, which is going to make a 3-dimensional shape. So here you have your cubic structures, and here you might have something more of a hexagon. I have some examples as well. All of these minerals in front of you actually are considered to have a crystal structure. If you see, some of them have very distinct shapes. A crystal is just a 3-dimensional shape, and if you give the minerals enough space to form when they were being created, they would form into a specific 3-dimensional shape. Here is fluorite, and it's kind of shaped like a pyramid. It's very pretty. Okay, that's what you brush your teeth with. And then all of these is more like what you think of a crystal, where you have a good, kind of those jagged crystal shapes on top. Here's another good one of a crystal structure. But these 3 right here, they are considered to be crystal as well, have a crystal shape. This one usually forms in that parallelogram shape. You got this very blocky, rectangular. You have galena, which if given enough space forms in a perfect cube. So all of these are good examples of a crystal structure, which is just a 3-dimensional shape. Next, we're going to move on to the different properties of minerals. There are 4 specific properties that help us identify the minerals. So we've got this pile here, and we don't know what each one of these minerals are, but if we used our different properties, we could start to identify them. The first thing that we're going to look at is how they look. So of course you're going to think of color. Yay, definitely you could use color. But one bad thing is color is not reliable. These 2 right here are both fluorite. One is green, one is purple. So in that instance, color is absolutely a really bad indicator. Another one. Well, they're both green, but they are not the same mineral. This one is golden color, but it is not gold. So although color is one thing that we look at when we're looking at appearance, it is actually the most unreliable form. However, it does fall under the category of appearance, so it must be considered. There are some times when we look at a mineral and the color does help us kind of think about what it is. Another thing about appearance that we can look at is a streak. So I have a streak plate here, and If we look at the streak that a mineral makes, that one is gray. It has a gray streak. This one is graphite. This one is the one that your pencil is made out of. Pencil lead is made out of. That one has a gray streak. This one is kind of bluish gray in color. And what's interesting about this one is it has a brown streak, even though it is metallic blue silver. This one's called hematite. The second thing that we might look at is how the mineral breaks. So it's either going to have cleavage or it's going to have fracture. If you look at cleavage, cleavage is going to have these really nice smooth edges. If it breaks, it's going to break off nice clean lines. Sometimes it will even break in that same specific shape. So these two have really nice flat edges. They're going to have perfect cleavage when you break them. Copper, on the other hand, there isn't any nice smooth edges here. This actual piece of copper is very jagged, sharp. You have this piece right here of quartz. These don't have nice edges. They're really rough. And for the sake of science, I can't believe I'm going to do this. I'm going to take the hammer and actually prove to you how a mineral will break into the same shape or possibly into a bunch of different shards, which would show its fracture. So let's take this hammer onto the ground here. Oh, there we go. Look at that. It broke off into irregular little shards. So I'm going to break that up. Yep, total smash pieces. It does not have clean lines. Now, this, on the other hand, was a nice piece of halite, the one that you guys licked in class and tasted all salty. I thought that it would have fracture, so I took my hammer to it and I smashed it. Ka-ching! And look what happened. It broke off in really nice smooth edges. So after doing this experiment, I realized, wow, I was totally wrong. It actually does not have fracture. It has cleavage because it broke off very nice, can you see that? Very nice lines. Which is nice because then I didn't have to break my galena, which I love so much. But for the sake of science, I will. This is a little teeny piece of galena. It already broke off the bigger one. It should have some nice cleavage when we break it. And again, it broke off in very nice flat lines, leaving good flat edges. So the difference between cleavage is here is cleavage. And don't look at that part. Here is cleavage when it breaks. Here is fracture into little pieces. So, fracture, cleavage. The third thing that we are going to look at is hardness. And basically there is a scale called the Mohs hardness scale, and it determines how hard a mineral is and puts it on a scale of 1 to 10. 10 is the hardest mineral that we have. That's going to be your diamond. No other mineral can scratch or harm the diamond. It is much too hard. It's actually about 3 times harder than corundum. Now, talc, on the other hand, is extremely soft. It can break off very, very easily. This makes your chalk that you use on chalkboards, and then your graphite over here, graphite is really soft too. So it's able to make a mark with your pencil because little teeny pieces are actually breaking off because it's very, very soft. On this picture, it shows a person's hand, and that's because your nail is a 2.5 that it is actually hard enough to scratch and damage a lot of minerals. So if your nail can scratch it, it is less than a 2.5. If a steel file can scratch it, it's a 6.5. If it can scratch glass, then your mineral is at above a 6, at about, I think it's about a 6. So we use a scale just to help us. As you remember when I tried to smash the quartz, yeah! Oh, did you see the spark? Well, this one's very hard. As we know, this is a very hard mineral. The quartz was too hard for me to even hit with a hammer. So this is a pretty hard mineral. It's actually a level 7. It can scratch glass. It can damage a lot of your other ones. This is that type of stone that you really find in the woods here in North Carolina. Very hard mineral. It looks similar to some of these other ones. But the difference is this one can scratch glass This one is so soft that I can actually scratch it with my fingernail. You can hear it being scratched. And then look at that. Can you see the particles on the table? It's so soft that my fingernail, right here, can scratch it. But my fingernail cannot scratch this because it's way too hard. It would damage my fingernails, and we don't want to do that. The last thing to look at for your mineral properties are these special properties. So maybe under ultraviolet light it glows. And surprisingly enough, I have one of those. It's right here. But I do not, unfortunately, have the ultraviolet light to show you. But this one under light will glow. And sometimes you could do the acid test on it and see if it bubbles. But I've got some other ways. Let's see here. Magnetite. Well, it's magnetic. As you can see there, it sticks to it. So, this rock, magnetite, is named because of its magnetic property. Okay, another special property is the scent. This is sulfur and it stinks. Smell it. Ooh, PU, doesn't that stink? It totally smells stinky. It's made for fertilizer, gunpowder. I believe they have it in fireworks, and it's cool. Smell it again. One more sniff. Okay, good. So basically that is our unit in a nutshell on minerals, but you might say, you know what? Okay, so I got these minerals. I know how to identify them, but why on earth are minerals important? My awesome chimenea made from minerals. Into the restroom we go. Toilet made from minerals. Sink, minerals. Deodorant, minerals. Toothpaste, minerals. Can you imagine what the world would smell like without minerals that made your toothpaste and your deodorant? Not so good. Ladies, your makeup, minerals. Flat screen TV, minerals. All of the wiring and copper that is in the electronics of your TV, minerals. Laptop, minerals. Window glass, minerals. All of the electricity, it's minerals. Mirror, minerals. Refrigerator, minerals. Tinfoil is minerals. The sink, minerals. These aren't minerals, but this is my family. Aren't they cute? Jackson and my sister Christina and my dad and my old dog. Me when I was younger. Not minerals, but we can't survive without them. Cars. You guessed it. Minerals. Minerals make this happen. Minerals make the world the way it is today. Without minerals and also rocks, we would have a totally different life. We would not even be able to have this little lamppost right there that provides me some light when I'm walking into my house. So without minerals, I'd be walking in the dark. So don't you walk in the dark and study for your quiz.